So everyone talks about blockchain today, and there are many forums which talk about how to use blockchain in e-governance and how to use integrating AI together with blockchain, and how to make blockchain now in the payment gateways, and how to make use of the advancements of blockchain in IoTs, cyber physical systems. Many are coming up. So we have seen that there is a big boom of like applications of integrations within blockchain together with in many domains. So as we move on seeing how beneficial blockchain integrations are with all these applications, and many domains have started adopting it, but still there are like lack of awareness of what exactly is blockchain. So everyone speaks on blockchain relating to cryptocurrency, and whenever there is a discussion on blockchain, people ask me how Bitcoin is related to blockchain, how cryptocurrency is related to blockchain. Why is this generally people speak on like smart grids, bitcoins together? So there are a lot many confusions why cryptocurrency is related to blockchain, and how is it like e-governance related to and black market. So all these are related queries. So let us have a understanding of what is blockchain, how they are differentiated when we speak about how blockchain can be used for governance, what are the types we have, and how we can say that when we try to adopt for an application, why exactly we need blockchain, what are the applications that can be used when we try to integrate blockchain into it. So to start with, the general opinion of why blockchain or what is blockchain. It is a technology where you can say that it is a cryptography based, where you have a provenance with an identity which uses of digital signatures, and it has an assurance of identity, authenticity. So whenever there is an access, it has some access rights for reading, writing into a ledger. So there is two divisions. So we will see on detail on what are the types of two blockchains, that is how it is getting categorized. So there we will understand why it is specifically used for cryptocurrency, why it is specifically used for other applications, and some general usages is like whenever we talk about blockchain, they are more related to financial transactions, and why not only for cryptocurrencies, why it is now getting integrated with even for RBI applications, why even now it is used for the NPCI fast tags applications. All these things we will come to know. And now it is getting integrated to many real-time applications. There are like a mechanism in blockchain which assures that there is no mechanism which can mute or change the historical records that is already inside into the ledger, or already there is something that is moved into the stored uh, part of the blockchain that cannot be changed, or when there is a try on to see there is a change, it can be understood that there is a try to change the records that is already stored. So there is a wide audience that can simultaneously see or read the content inside a blockchain. So these are some of the things that is generally with a blockchain. So I refer to some of these blogs that is already written by IBM, as IBM is a major guy who has come up with so many versions of frameworks. For example, the major frameworks that is now being evolved as an open source or as a commercial source, for example like a hyperledger, these are like versions that are evolved from IBM. So I have taken these resources from IBM and just citing them. So in general, we can say that blockchain technology is a digital ledger, and in other terms, to add on the other feature, it is said to be distributed, so that it is not in a centralized place. It is distributed in across and is synced up in between, sitting in different places. So it can be in a single node, it can be in a multiple node, and these are immutable. That means like once it gets into a place or into a state where it is said to be synced up and kept, where it is what to say, in a position to say it is in a ledger, it can never be altered. So it is a historical data now. It has one way of hash computed and kept, so that that records can never be changed or altered in the next stages. And these are like, as I said, it is distributed across and can be read or accessed by different entities that is simultaneously accessing it. There is a transparency in among the people who are participating in the blockchain. So these people who are participating in, for example, like a public blockchain will be like accessible to everyone. Maybe in a private blockchain it may not be to everyone, but to the people with their access restrictions that is set by the blockchain policies. So some like cryptocurrencies, Bitcoin, Ethereum, that we will come across, they are said to be the public blockchain networks. So they are some of the technologies that is very popular. So people seems to be very familiar with these terms. So these are some of the things that are generally discussed whenever we say about blockchain technology. So these terms generally people come across whenever they read about blockchain technology. They say ledger. Ledger is not a, uh different term. So it is the general term which means like a storage. So ledger means a storage. This ledger is distributed in blockchain. So once this ledger is populated with something in blockchain, this is termed as a transaction. So anything that is exchanged which is in terms within blockchain is termed as a transaction, gets into this ledger, that is a storage. So these are the shared exchanges in between. So this becomes immutable, and these are decentralized and doesn't have a central authority to control it, and hence it have a over democratic control over within the network, and these are immutable and cannot change the history of all these records, and they are cryptographically secure. So there are some encryption mechanism that is involved, and hence there is an integrity assurance within the records or the data that is stored inside. And there is a smart contract that is involved that ensures that there is an automated agreement that each entity gets into when they get into this network, that is it, into the blockchain. So these are some of the general terms that we speak, or like general things that we come across when we first start learning about the blockchain technology. These are otherwise termed to be the feature sets when we say about blockchain technology. So I told in the beginning itself, there are like two types of blockchain technology with which we will come to understand why we have these confusions, or generally people have a mindset of saying why cryptocurrency, why they are used for bitcoins, or why they are used in black markets, why government is not encouraging cryptocurrencies, but still they encourage blockchain to be used for e-governance, and why ransomware attacks are happening, asking for ransom payments using bitcoins which use blockchain as their platforms. All these confusions comes because there has a basic understanding that the underlying technology what they use is blockchain, but a type of blockchain is different for these applications. So whenever this Bitcoin or cryptocurrency is involved, the type of blockchain what they use is a public blockchain. So public blockchains are generally used for these type of an application where and anonymization of the people are involved. So here, the wallets of the owners of the entities that get into the blockchain will only be known, and the people owning the wallets will not be known. So these identity will be hidden. So if you want to backtrack the wallets, you can just reach only the wallet address. You can't reach the identity of the person. So any person who want to exchange money or want to send a request for a money exchange, he can just give an address of his wallet and ask them to send the money. So this anonymization with which he can hold his wallet makes it him or her to hide his identity and make him comfortable to do all illegal business. That is the reason why all black market businesses runs using this black cryptocurrency exchanges, and which runs over this public blockchains. So when we talk about this public blockchain, there are few things more. Authenticity whenever there is an exchange for any transactions. And the second thing is that there is no requirement for the consensus mechanism that involves a different structure, like that is not requiring more than like a governance system like how it is emphasized in a private blockchain. For example, if there is a governance policy or mechanism that is involved in a private blockchain which emphasize that there is a validator group, for example like a land registration system, which says that there should be a registrar, there should be one tahsildar, or there should be two or three hierarchy people who should validate and then ensure a transaction should be proceeded. Such validation procedure will not happen in a public blockchain. It just says that if there is more than 51 percentage supporter for a transaction, this transaction can be validated. Or for example, if there is another way of saying there is a mechanism of a new protocol which says that there are more way of saying a rewarding mechanism, in that case the transaction can be taken forward and can be added to a ledger. So the mechanism of how a transaction can be executed totally varies from how it happens in a public blockchain and a private blockchain. So in this way, this mechanism of how this transaction itself gets executed in a public blockchain and private blockchain varies. So that is the reason why it is said to be the emphasis of using private blockchain in e-governance mechanisms, and public blockchains are generally used in all black market exchanges. So these public blockchains are generally used in mechanisms like cryptocurrency exchanges. The common ones are like Bitcoin, Ethereum, etc. So private blockchain examples are like Hyperledger and Corda, etc. So many of like our Ministry of Information and Communication in, ministries have funded projects which are said to be like national blockchain frameworks, with where there are many national services getting hosted over blockchain. For example, like a e-praman system, land registration system, supply chain, drug chain, all getting hosted over private blockchain. So we are using Hyperledger for such applications. So these are some of the general differences between what a feature sets that differs public blockchain from a private blockchain. A small list is listed out just to read out. Generally, public blockchain have low performance. There are scalability issues. They are totally with anonymizations, and they have limited privacy and confidentiality. They have storage constraint. They have unsustainable consensus mechanism. They have a lack of governance and standards, and they are not suitable for enterprise where privacy and confidentiality is needed. In private blockchain, there are restrictions in access, and also whenever there is a access in network. So the participants are defined, and they also need to be identified, and the network permission need to be availed, and there are high transaction throughput performance required. There is low latency in transactions, and privacy and confidentiality of transactions are required, and decentralizations within the involved parties. The governance is enabled within this private blockchain. So private blockchain are much more comfortable in getting managed. So hence is the reason why they are generally used in e-governance mechanisms. So this is how a blockchain technology works. So whenever A want to transfer something to B, it is a transaction request. So A first have to get authenticated into a blockchain network. So if it is a private network, there will be some authenticating uh, mechanism, for example, like a LDAP or a certifying authority, which will issue a certificate or which will issue some type of a key generating mechanism with which it can confirm its identity, with which it will get into a network. And later on, after this identifying procedure is done, a new block which is created to represent the transaction will be done, and this block will be sent across to all the participants in the blockchain, imagining that this block with which this transaction is communicating is with the channel that every participant is getting involved. Okay, so once this nodes that is validates all these uh, blocks that is in the transactions, then this new node that is getting this transaction approved will get this transaction complete, and then this block will be updated into the blockchain. So this new block that has been invoked by A, after it gets validated by the other nodes, will be added into the blockchain. So after this, this will be added, and this is called a proof of work. As most of the cases, the nodes that is validating this will be rewarded for this. So the most cases, whenever there is a use case, what happens when there is a blockchain integration that happens with this use case? Generally, there are many use cases, but whenever this blockchain comes into the picture, what extra feature sets it gets by integrating a blockchain? So one good reason what we say is immutability. So once a transaction happens, there is no way that it can change a historical data, or there is no immutability that is possible for a historical data. So this will reduce the data breach cases. So there are cases where we have seen that land record data, once after a while of like 1 decade, 2 decade, or like 5 decades, there are changes in the land records once it gets digitalized. So these things can be avoided by moving these use cases into a blockchain. And there is a transparency. So when you have like transparency in among people who are getting involved into this, there will be a copy of this data with everyone who is participating into that. So this reduces the complete or like 70% of the data discrepancies. So it depends upon who is the application holder and what exactly is the application where you require the data transparency. So with the use case where you require all the participants to have a transparency of data, 70% of a reduction of this data discrepancies will be there. And security is another plus point that you can confirm with the integration of blockchain into this use case. So you can ensure that there will be assurance that once the blockchain gets integrated, there will not be a hacking mechanism. So even now, there are some use cases where they say that even to avoid the AI models getting hacked, you can integrate this AI models into blockchain. So this will avoid the hacking of the AI models uh, by assuring that these are completely kept secure. So these are some of the futuristic things that researchers are exploring. So some of the key industries now exploring or now utilizing blockchain are like finance, healthcare, supply chain, governance, etc. So in finance, we have seen that there are secure transactions that are happening with the blockchain, and there is a complete enhanced transparency that is assured with the blockchain concept. And we can see that the cross-border finance system is completely booming up with the blockchain integration. So right now, the cross-border transactions, which is generally happening with the other technologies, is taking a minimal time of around like 1 day, which is more than what is bearable for uh, Indian perspective, as the trading is increasing to a great extent. That is what is the general discussion in a business forums. So, as with the integration of blockchain, it is seen that this transaction speed can be increased, and this uh, time duration for this cross-border transactions can be reduced. So with this, there will be a increase in the speed of this transaction, and the security of these transactions can also be increased. And the next domain where there is seeing like a promising area is the healthcare. So now with after the COVID scenario, we have seen that people are more concerned about the privacy of the health records or the patient data, where everyone have started seeing on their health records using smart devices, and we have all uploaded many of our data to various applications like Arogya Setu or many of the other applications where we had our tracking of our locations, our privacy data, and we were not sure like how long the data were there and where our data were stored. So these worries were kept worrying us for a long time. So there we had a eye opener, like all these data need to be stored in a very secured manner. So now there is a very high time that everyone has started thinking on these data need to be stored in a secured manner, and blockchain is a one good method where which the privacy of the data is kept in a very secured manner. And so this is one area where everyone have started getting explored. And there is also one booming field where everyone have started exploring, that is the integrity in clinical trials. So whenever there is some test records that is kept in some storage space, there is either in a cloud or in a private storage areas, for hacking or to get into the health uh, space where there is a requirement for a bio ward to be placed, people have understood that the change in the health data or the clinical trials records can impact the total uh, changes in the citizens' health or the uh, common man's health records in a country. So this had made a great concern in all countries. So this had put everyone to see how these data can be stored in a secured and in a very encrypted way. So there came like many discussions on how to keep it in an immutable way, how to keep it in a privacy secured way, and how to make it in a privacy enabled way, such that even if it is used for some statistical purpose, it can be used in a privacy enabled way. So there came the concept of homomorphic encryption. So these are some of the research areas which have boomed up after these discussions. So healthcare is a domain where blockchain have come to a very good maturity. So there we have seen that privacy has been one issue that have been resolved with the introduction of blockchain, and immutability of the health records after the clinical test recordings. These are the two promising things which was assured with a blockchain integration. And the third thing is the supply chain. So in across like all countries, there is a issue of like uh, uh, war surfing across, and the hardware electronics that is imported from different countries seeing vulnerabilities, like the Lebanon pager blast, or the semiconductor industries which are seen to be vulnerable, which have uh, provoked all countries to stop importing and getting into their own production of uh, semiconductors, designing of their own chips, Atmanirbhan, all these things started getting evolved because of seeing the threat that is coming up from the nearby nations, or understanding the threat that could be created due to the imports from different supply chain issues. So if blockchain is getting integrated in supply chain, there could be a promising result to understand or to ensure the authenticity of the supplier or the country from which the supply is happening. So this ensures the efficiency and the transparency of the supply, and this is one promising place where blockchain can be used. And governance is another place where blockchain was keep on like proving its provenance, because all these either citizens and also the governance administration all required a transparency to completely see the democracy still holding their position, and to see all the privileges services provided in a good way, where still both administration and citizens feeling happy of all the schemes getting employed and services going on very well. So to account all these things happening very well, if governance can be moved to the blockchain, that will be a best place where blockchain can be used and employed very well. So, what are the other major use cases where the blockchain can be used? So, these are something which we have already discussed, but general discussions whenever we see the blockchain, these will be the main things that I have seen. So, just thought of putting it in a slides. Public utilities, for example, in uh, power grid, there are few discussions that have already happened, and I have seen that the power grid technology, as they have already faced one failure in Mumbai sector in 2017. They already have such a discussion to move their power grid architecture to blockchain, and such discussion have been already ongoing, and this is in a high time that they are thinking of integrating it, and to ensure the cyber security measures, they are trying to move this to the blockchain technology. And there are like few mechanisms which are assuring that blockchain renewable energy credit tokens are distributed. So now everyone have started speaking about using the solar energy panels getting installed in their terrace. So they are saying that there is subsidized rates with which government is giving the panels where it can be employed in their house terrace. and even energy distribution from their terrace to the government can be given in some rates where government will pay for them. So these are generally given as some tokens. So there are some measures where these services are now ready to get hosted in blockchain. So these are said to be the blockchain renewable energy credit tokens. So there are discussions where these services are now getting hosted as tokens, and Ethereum is planned to be the platform with which this is getting hosted. And even financial transaction, as I told, we have some mechanism with where retail consumers and utilities can get benefited with this secure payments. FASTag is one such discussion that is going on. And in energy generation and distribution, it's already in discussion. And infra management, I am not very sure, but I know discussions are going on, but I am not very sure about the specific use cases where it is being used. And in logistics and supply chain, yes, there are several trials and discussions, even in the private and even in the government level, to understand how blockchain can be used. There are many POCs done and many failures. So even the very recent one in a private is like the Amazon and even the Walmart, very recently done with IBM, with a food chain that is done very recently in 2024, got failed, which is to which got compromised by the private key uh, leakages. So there are efforts going on to integrate the logistics and supply chain integrations, but still promising results are yet to come. But there are many benefits in doing it. So there are many untrusted intermediators who will be removed when these integration happens in a very systematic way without any flaws gets integrated. So this reduces the cost and also the delivery time. Overall, there will be a big performance improvement when blockchain comes into picture. So healthcare, we already had a discussion, so I'm not getting into this. So even in the digital currency, which RBI is speaking about, there is a discussion on bringing blockchain inside. So there is one big boom that we can expect when NPCI introduces digital currencies in India. So record managements, already there is Karnataka and Telangana who is doing this land record registrations using blockchain. So in physical signatures, there is a lack of security and trust in the signer. So with a blockchain smart contract, you can validate the signer using a private key. So in this mechanism, there is a decentralization in this automation process. So the third party's role is totally removed from this. So complete transparencies between the people who get engaged into the contract is there. So all the intermediators who is getting into it and all forgeries that is involved in this can be uh, completely eliminated with this. So this digital health pass, this even had a big boom when COVID time was there. So this version was introduced during uh, COVID time with a blockchain integration, but this didn't pick well after the COVID. But still, there are more such plans for integrating these type of healthcare records in blockchain, which is still seen as a promising new area where everyone will have privacy preserved health records stored in uh, these type of services. So as we have already seen, so these blockchain works with the help of these validators who are said to be the governance policies makers as per the private blockchain what we are discussing, which can be used for enterprise level or e-governance. So these validators are chosen by the enterprise or the governance people who can be the administrators. So they decide on what type of a consensus mechanism they use to validate the transaction. It can be a proof of stake, proof of a work, whatever. So with this, they will confirm like, okay, this is the way how you will validate the transaction that comes to them. And once they validate, okay, they make the block and they block and then get into the ledger. So this is how the blockchain works. So now we are getting into the core part of our discussion. Why data integrity? So is data integrity only assured with blockchain? No, this is one of the feature sets which blockchain assures. So this is why I was discussing more on like blockchain features till now. Data integrity is one such feature that blockchain assures, and with which there is more like things that can happen in many of the applications. So data nowadays is a valuable assets, and we know for each of the data that is leaked outside, we are or anyone who leaks it is getting paid. So any compromise of data is a financial loss or a damage of a reputation, either for a person, citizen, or a country or an organization or at any level. So this refers to for any data over in its entire life cycle should have an accuracy and reliability. So anytime in its life cycle, it should have the complete structure preserved asset. So any type of a consequences in its loss could impact at a high level. So when we talk about blockchain to assure the data integrity, so blockchain has two ways in which we can say that data integrity can be assured. One is the cryptographic algorithms. So cryptographic algorithms are to secure the data. So generally it involves the encryptions with which it ensures that the integrity is maintained. And the second thing is the hashing mechanism, which also says that this integrity mechanism is maintained. And there is also a decentralization with which there is like no single entity which controls the data, and it is completely like distributed. So this enhances the transparency and the trust, so that we ensure that even if there is one change, either due to a failure or there is a mutation or due to a intended change that has made by a single entity, it will not reflect to the centralized or the complete changeover in the data sets that everyone owns. So this assures that the data integrity is still maintained. So this is how the data integrity is maintained in a blockchain. So the hash identification is the one main thing that we say that it is highlighted in a blockchain. So this assures that it ensures the data integrity. And proof of work, that is the consensus mechanism that is used in among the validators, which ensures that this once validates the transaction and gets this block into a ledger, will never make the immutability in the ledger. So even if there is a change or a reflection in the uh, transaction details, this will again be a different entry in the transaction. For example, you are initiating a transaction saying that, imagine a case, you have an application which is doing a payment. I initiate a payment of like transferring an amount of 2000 from A. I am A. I am transferring it to B. A initiate transferring 2000 to B, and I am validating this transaction among different validators, and everyone validates it, and it gets validated and gets into the ledger. Now I am doing something and I want this to be corrected. So I wanted this to be changed over, which says that This is a changed transaction which says that the 2000 is modified to 1500 with a different entry, which doesn't mean that this entry is changed. It will be a different entry updated in the ledger. So if it is line number 11, there will be a different line 15 which will be saying that transaction amount 2000 is changed to 1500, saying that a transaction 1500 2000 requested for a change to 1500, which is again validated and requested for a change from the validators. So this is how it will be reflected. So this is how it happens in a proof of work. So nowhere there is a mutation that can happen in the ledger without the consensus that happens in among the validators. There is one more thing called a digital signature. So as like the physical signatures, these are called digital signatures, which are used for authenticating and confirming that there is no tampering in the data. So these ensures they are tamper proof data. So these are the main cryptographic things or mechanism with which the data integrity is ensured in the blockchain. So the procedural way to say that how to start with in ensuring a data integrity. So the first mechanism is to implement a hashing algorithm to create the hash for the data blocks. So first you will create the data and you will create the block which contains the data, and you will create the hash using a hash algorithm. So there are different type of hashing algorithms. In general, the regular hashing algorithms that is used in blockchains are hash 2 and hash 3. So hash 2 mostly are like discouraged, hash 3 will be used. And then the decentralization, that means the distribution of these things in among the nodes to validate the transactions. So this will be distributed to validate and to confirm the transactions. So once this is done, there will be a transparency of this transaction in among the different ledgers, and this will be recorded. So this ensures the transparency, and with the smart contract, which is an automated agreement, your data will be verified. So once smart contract is executed, your data is verified. So once verification is completed, you are to ensure you have a enhanced security, you will sign these things with your digital signatures. So this is one way to ensure that you are authenticated or you are the concerned person to authorize and do the transaction. So this is the complete flow of how to make sure that you are doing a blockchain based data integrity assurance. So these are the procedures or the phase wise manner how the integration procedure happens. So I'll just uh, give this integration architecture with an example. So here we can see there are two entities. One is a data owner and another is a data demander. So these two people are getting private keys which are shared with each other. Like these people have private keys which are shared by an authorization center. So they have the keys with them with which they are going to access a file. Okay, so the file, the data that the owner have to share is first encrypted, and then it is loaded into the inter IPFS file system, and there, once it gets encrypted, the hash value of the same is retrieved back, and this, along with the data records, will be stored with the hash value in the blockchain. So the details that is getting stored as an entry in the blockchain will be the hash value of the encrypted data file systems and the data record details. And this will be then stored in the ledger. So whenever the data demander needed, he will be accessing and getting the hash value of the same along with the download of the data ciphertext. So he will get the hash value. As he has the private key, he will understand the hash value and the private key decryption, and then he will send this details and he will decrypt the files here. So this is how he uses this mechanism to understand the data sharing mechanism. So here the complete mechanism of this sharing happens over the blockchain. So the mechanism of encryption and decryption with the private key exchanges happens with the help of the authorization center. But all these record sharing, hashing mechanism records, all these happens over the blockchain. So the hash value computed along with the data record details is only stored in the blockchain, and these details helps them to retrieve the uh, decryption details and then retrieve the decryption file itself from the IPFS file system. So in this way, these type of an integration would help us in this type of an application. So these are some of the platforms, like as I told, there are multiple type of blockchain frameworks that are available. The famous one are the IBM blockchain platform. Another one that is a open source Hyperledger Fabric, which is very modular and very famous. It's a private blockchain. Ethereum is a public blockchain, and Chainlink is another public, and Factom. Many are there. So to understand like these blockchain when they used for data integrity, what will be their rating? So just with few of the feature sets, how it would be rated. These are listed there. I prefer in using Hyperledger Fabric with most of its feature sets. The only issue is there, they don't have their modules more suitable for the governance as such. So to make it suitable for governance models, we have to write our own APIs and make them integrated into its libraries and then use them. So I would prefer this comparison to be seen and then used as based on your application for which you are developing it. So the people, maybe like faculty members, many of you are getting involved in different type of research. So just to give an overview of how blockchain integration can be used in IoT, if you have some data integrity verification in IoT, just a use case with my own knowledge of a general understanding of an IoT integration with blockchain. So the general case study of how the data collection happens in a CPS, but once blockchain comes into picture, the overall scenario, how this works with the Ethereum node, which acts as an uh, client sitting as an intermediator to connect with the blockchain network, and then reads data, and then ensures that whenever the data gets collected, it keeps inserting the data, and then assures that the data is kept recorded without moving or immuted whenever there is uh, any change that is abruptly coming without uh, uh, big variations. So that is being recorded here. So the general schematic diagram is given for a general understanding. So people who are already into it will have a general idea to understand it. So another upcoming blockchain trend is, oh, I'm sorry to say, this is optimize. I had a typo. So here we can see that there is an increased interoperability that is now as an ongoing trend. Earlier, the public blockchain interoperability was not there, but now we have seen that Ethereum has moved to operate with the private and public blockchain together, which is a growing trend. So there is a seamless integration for communication, and also there is a data transfer from one blockchain to another, where the way how the data required to be inside the ledger itself is totally different, but now there is a compatibility that is possible now, and even the offload of the transactions from one chain to another chain, it is now possible within the different type of chains, and the scalability is now also getting enhanced. Now blockchain is also used along with AI and IoT for different type of feature sets assurance, like for overcoming the anomalies, and also to assure the data provenance, etc. I was speaking on the plus points of what blockchain can do or help out, but there are many challenges when we talk about adopting blockchain. Even though government have many encouragements on adopting blockchain in governance, there are many regulatory compliance issues still blockchain is facing. There is no standards still evolved to directly adopt a blockchain into e-governance. There are many BIS standards to uh, adopt a distributed ledger, but there is no direct standard to evolve the distributed ledger into e-governance. So there are standards to use blockchain for e-learning. There are standards for using blockchain for privacy, but nothing for e-governance or national services. So such policies still are yet to get evolved. So still then there is a guidelines or policy issues or regulatory frameworks still getting confused. So law still doesn't completely say that yes, it is yes to be allowed or not to be allowed. So legal uncertainties are still there, and interoperability issues are still not completely patched up. The public-private blockchains are still like holding the legacy systems, and hence the lack of interoperability is there. Even if the open source blockchain, which is said to be the Hyperledger, which have the complete modularity, doesn't open up its full libraries. So actually, me and my team who sits in sets, we are working with Hyperledger Fabric, where we have opened around like the 8 layers of the stacks, where we work with the identity and the key management layer completely, and also the quantum layer, where we work with the post quantum algorithms mainly. So where we see that so much of non-transparent issues are there, so still the legacy of these open sources are there. So we cannot claim that uh, the open sources are still not uh, completely open make it completely to say that they are for the research and open for the people to do their research there. So the holding of people to still claim that the legacy systems are not there, it's not correct. So there is a lack of interoperability, and there are like fragmented ecosystems still there, which will make still things worse. So there are many problems between the public and private blockchains, and the scalability issues when we see that there are high transactions data in certain applications, the scalability problem comes. So it causes a slower processing in certain application that may not be suitable in a live production environment. So to overcome these issues, there should be some level of POCs that need to be checked, or distributed environment implementation that need to be checked. So to understand it in a better way, there should be a skill set development that need to be done at the POC level, and then only it need to be checked at the live environment. Yes, this is from the my end. So I would like to take up some questions before I end up. Any questions?
Good evening, ma'am.
Yes, ma'am. Yes.
Ma'am, actually, the blockchain has implemented now in future with high risk, so that how can we avoid the risk in blockchain technology?
Uh,
Financial and currency exchanging and everything is having high risk. So the potential deliverance, can you use any specified algorithm for this, for implementing, to avoid risk?
Uh, Ma'am, can I rephrase your question? You are asking like if
Yes,
blockchain can be used for financial transaction,
ma'am.
is there any risk
Is
in?
there for implementation based, we can use any specific algorithm for preventing that risk?
Ma'am, using blockchain for financial transaction doesn't involve any risk as such.
Okay.
It is said to be highly secured. But the problem is that if you are using it with a public blockchain, your wallet will be
Okay.
your account address,
Okay.
and your account address will be linked to you, but as like your general account transfer, you will say what is the name holder, account name holder, what is your bank IFSC code. All these details will not be required by the other person who is sending money. He will just require only your wallet address, nothing else.
Okay. Okay.
So the only transparency he will have is
Yes.
your wallet address,
Okay,
that's it.
ma'am.
There is one question in the chat box.
Please check your chat box, ma'am.
Sure, ma'am. If we want to store patient records, do we need any specific database for storing, or we can store only in block itself?
தம்பி இது என்ன
Okay.
எனக்கு சேட் பாக்ஸ் வர மாட்டேங்குது.
Okay, okay. Ma'am, actually, to speak on the patient record, for example, it depends on the size of your data. If the patient data is too big, you don't want to store that directly into your ledger, then in that case you can store it in your database, and you can make the database entry into a token, and that token can be stored into your blockchain. But if your data itself is too small, then you can directly store the data itself into your blockchain. That depends on the size of your data. That is what is the answer for that question. Then the next question is, ma'am, is it necessary to
Reshmi ma'am, you are muted.
Yes, ma'am. I'm just reading the question. Ma'am, is it necessary to use blockchain Oracle to connect to external APIs for fetching data from external entities, or is there any other way? Yes, ma'am, it depends on the blockchain framework. For example, if it is a hyperledger, you can have even REST API that can be used to fetch. So it depends on the frameworks. So any APIs can be used. So specifically, if there is some blockchains which have restriction, then only there is a problem. Otherwise, any APIs can be used. So can you suggest some database for blockchain? So actually, database is not required for blockchain. So if you want something to be stored in database and then have that compressed form to be taken as a token and then store that into a blockchain, that is a different story. Even something you can store it in a data structure, and then that also can be stored into a blockchain. So all these are implementation issues. So how to implement that is different. So this database, data structure, all these are the way how you implement. And another thing is, I am using Ethereum to deploy smart contract. I wanted to add some external data as well. Okay, that is fine. That doesn't have a big problem. Smart contracts, you can just pull it using external APIs. That is not a problem. Can you suggest some data sets for blockchain? Data sets for blockchain. That I am not very sure. Maybe like it depends on the application. Okay. Anyway, thank you, ma'am. Ma'am, I can share the email address.
Ma'am, one more question, ma'am.
Yes, yes, ma'am.
How is integrity verification done in blockchain, ma'am?
Ma'am, almost like everything is checked with data integrity, ma'am.
Okay.
So it is 100% assured with data integrity.
Okay.
So my Gmail address has been shared. So if you have any more queries, we can catch up offline also.
Okay, ma'am. Thank you, ma'am.
Okay. Anyway, thank you for connecting. Thank you for the opportunity to all the organizers. It was nice.
Actually, we have one photo session now
Okay.
for a group photo. Please, everyone, switch on your camera.
Okay, ma'am. Thank you. Ma'am, I have a problem with my camera, I believe, but still I will
Why,
do
ma'am?
it. I don't know. It is showing there is a
One
device.
second. One second. Okay. 1 second. Not.
Amada ma'am.
Yes, ma'am.
Resh, we have 10 minutes more.
Okay, Reshmi ma'am. Thank you, ma'am. Thank you so much.